LeetCode Problem 4, median of two sorted arrays. Right, so this problem gives us two sorted arrays, nums1 and nums2, and then we have to return the median of the two sorted arrays, right? And our time complexity should be log n plus n, right? So basically this means that we cannot just merge two arrays together and then find the median by just size divided by 2 because by merging the two arrays, then it won't be log m plus n anymore, right? So this means that we need to use some sort of binary search, right? So this solution I have is a bit lengthy as the problem is a bit hard, but I'll try my best to explain. So what I do first is I find the size of both the arrays, right? We'll call it n1 and n2. And for this to work, I actually need the n1 to be the shorter array of the two, right? See, that's why you can see that I have a recursion that basically uh, puts num2 in num1 if num1 is bigger than num2 at the size, right? But other than that, I have a total, right? So this total is to compute the total size of both the array, and then I have a left pointer and a right pointer, right? So we'll be focusing more on the num1, and our goal is to basically our goal is to basically uh, have two arrays, something like this. Oops, something like this, have two arrays that we can compare, and then see whether or not these two arrays are in the left side of the merge array, right? Because let's say if I have to merge this, right? Let's say then it will be like 1, 2, 3, right? So if I merge this both, it will be like this. So our goal is to see whether or not we can like split both arrays into two more partitions. I'll call them two more partitions, and then determine whether or not we calculate both partitions are the same. That means both both belong in the left partition of the merge array, and when we successfully got that, then we can just know the next number would be the median, right? Or the next number plus 1 divided by 2 if the array is even. Okay, that's why we need the total, right? So that we can divide both array correctly. I'll explain a bit more later, but let's continue first. So like I said, we have a left and right pointer and the right, and this left and right will mainly focus on the n1, right? Okay, after that, like I said, we need to determine how are we going to split both arrays, right? So the way I do it is I cut down the middle of n1, right? So if I cut down, then it will be, this is basically left 0 plus 3 minus 0 divided by 2. So this is basically 1, right? So I have separated the partitions to be like this, right? I'll just space it out so it's easier to see. Yes. Okay. And then n2, which is the bigger array, will be the leftover of the total, right? So remember our total, which is in this case is 9, right? So we need to plus 1 because it's 0 indexed, and then we need to divide it by 2. So 9 divided by 2 is 4, and then we need to minus our n1 index, right? Which is how many numbers we have partitioned, which is 2, right? So we need to split out 2 again. So right now it looks like this. Okay, after that we check whether or not the left side of n1, no, basically, oh no, my bad. This is basically to check whether or not our index is inbound, and if it's inbound, then we need to make sure the numbers are correct lah, right? Because if it's out of bounds, right? If it's out of bounds, then we need to put it to in min, right? Which is the smallest possible integer. Or if it's, yeah, basically if it's out of bounds in the lower part, then it's in min. If it's out of bounds in the higher part, then it will be in max. Okay, after that, we need to check whether or not the partition is correct. So the way we check is by comparing n1's left with n2's right, which is this number, right? So if this number is smaller than this number, and n2's left, which is this number, is smaller than n1's right, then this number, which it is in this case, then that means we know that the partition is correct, right? And in this case, it is correct, right? Just so happen that it's correct. And when it is correct, we will just check whether or not the total is a median. And if it's a median, or if it's even, if it is even, then you need to plus both of the right side, right? You need to plus both, and then divide by 2, right? If it's not, if it's odd, then we just return the maximum bigger number of the 2 lah, right? Bigger number of the left side of n1 left and n2 left, right? Remember that the n1 left is actually from the this side, basically here, and then the n1 right is basically n1 index, which is over here. Okay, all right. Let's make another example that is not so easy, so we can show the binary part, the binary search part. I'll just undo everything. Okay, let's say an example like, I'm not sure. Let's say I had a few more numbers, maybe that will help. 4, 6. Okay, take something like this. And then, right, n1 is still the smallest. Okay, our total, let me write it down. Total is right now 1, 2, 2, 3, 4, 4, 5, 6, 6. Right. Okay, so right now our total has 1, 2, 3, 4, 5, 6, 7, 8, 12. Total is 12. Our left side is 0, right side is n1 size, right? 0 n1 size. Okay, then while our binary search here is lower than right. Actually, let me just increase the number here so we can do more binary search here. 5. And I'll just remove the. Okay. Let's add a few more. 8, 9, 10. Okay. Let me redo this. 1, 2, 2, 3, 4, 4, 5, 6, 6, 7, 8, 9, 10. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right. So it's 13. Okay. Total is 13. Left is 0. Right is n1 size. Okay. Then let us determine how we're going to split it. So remember, we split it in the middle. So it look like this. And then here also, right, because it's total divided by 2 minus how many we have already split here. So right now we have something like this. Okay. Alright, so let's determine our n1 left and right. Right. Let me just write out here so we can easily visualize it. Okay. So if is our index more than 0, right? Let me put index. Okay. let's calculate the index. So index is left plus right, which in this case is 5, right? 1, 2, 3, no, 6 minus 0, and then divided by 3, divided by 2, this is 3. This one will be total. Total is 13 plus 1 divided by 2, and minus 3. So basically this one will get us 7 minus 3, which is 4. Wait, is it? Let me get that correct. Yeah, it's 4. Right. So it's actually like this. Okay. Okay, after that, then let us count the n1 left. So n1 left is our n1 index. N1 index is 3, right? So 3 is more than 0, right? So we can, so our n1 left is basically num1 with 3, num1 3 minus 1, which is this, right? 0, 1, 2, 3 minus 1, which is this. And then, so this is basically 3, right? Okay, and then this is the right side. So the right side will be n1, 3. Okay, right. So in this case, our n1 index 3 is lesser than n1 size, right? Remember our n1 size is our n1 size is 5 or 6. Our n1 size is 6. So we'll be looking at nums1 at index 3, which is over here, right? So this 4. Right, so we're looking at this. So this is basically the left side and the right side, right? So that's how basically what you're seeing here, this 2 is the left half, right? It's the left half. Okay, it's not correct yet, but just imagine that this is the left half, this 2 is the left half, and this 2 is the right half. That's why you can see right. This is the most left of the left partition, and this is the most right or the most left of the right partition. Okay, let's continue. So n2 left is 7, and then n2 right is 8. Okay, then we check whether or not our partition is correct. n1 left is smaller than n2 right. 3 is lesser than 8, yes, correct. But is n2 left smaller than n1 right? No, right? Because that means that this number does not belong in the left partition. Okay, and when that happens, we check whether or not n1 left, which is this number, is more than n1 left, right? This number is more than n2 right, right? It's not, right? So that means the left pointer have to move up, right? So the left pointer here, the left is here, have to move to index n1 index, which is 3 plus 1. Okay, so left is equals to n1 index 3 plus 1 is 4, and then right is still the same at 6, right? Remember. Okay, let us redo everything. Let's count again. Okay, so right now uh, we calculate how we're gonna split up our partitions. Give me a bit to prepare. Okay, we count how we're gonna split our partitions. So left will be 4 plus right 6 minus 4. So this is basically 2. Right, divided by 2. This is basically 1. Then it will be our n1 index is 5 right now, right? So we're gonna split it like this. So basically it'll be 5 numbers, 1, 2, 3, 4, 5. And then our N2 index is basically the total. Total, remember, is 13 plus 1 divided by 2 minus 5. So this is 14. Right, 14 divided by 2 is 7. 7 minus 5 is 2. Right. So here we will only have until 0, 1, 2. Alright, 2. Right. Okay. Am I making sense? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Okay. Okay, after that, we count again. N1 left, right? N1 left is basically here, which is 5. N1 left. N1 right is 6. This is 4. And this is 6. Okay, now when we do this, we check again the partitions. So N1 left is N1 left lesser than N2 right? Is 5 lesser than 6? Yes, it is, right? And N2 left lesser equals to N1 right? So N2 left is 4 lesser than right. Okay, so in this case it is. That means we have correctly partitioned our left side and right side. Okay, before we go and find the total, let's do it manually, right? So this will be like this, like this. So you can easily see that the 1, 2, 3, 4, 5, 6, 1, 2, 3. Okay, easily see that the median should be 5. The 5 should be our answer. But let's see what we get. Okay, so 13 is not even, so we have moved to our odd. Then we return the maximum of N1 left, which is 5. The maximum of 5 and the maximum of N2 left, right? So N2 left is 4, right? So in this case, the max is 5, and then we just return the max, which is 5. In this case, will be our median, right? So you can see this is how my algorithm works. It can be quite it's a bit lengthy and a bit difficult, but yeah, that's how it works. That's all I have to show. Thanks.